Chicka-chicka, chicka-chicka. That's true, yeah. Oh no, how do I do the thing? Ooh. Huh. No. Cool. Killing me here. People are not important. There are no people in technology, just replaceable components. Ooh. Oh, disappointing. Oh, hey. Cool. When should I start? So was that yes to do now? All right, let's do this. All right. I'm going to tell you about what Rust is, why Rust is a part of Mozilla's work, and when it's going to start being a part of Mozilla's work. Let's begin. So Rust is a new programming language that has been created inside Mozilla and shared with the outside world. The goal of it is basically anytime when you would traditionally, as a developer, have reached for C++ because you need a certain guarantees about performance, for example, we want Rust to be a viable alternative in every single case. There should be no reason to choose C++ over Rust in the ideal future. So it began as a side project of a Mozillian named Graydon Hoare back in before 2009. He started working on it full-time in 2009 because Mozilla saw the ideas that he had and said, we can see how we could put this into Firefox and make the product better if we actually had this language. So that's when we started investing time and resources into it. Fast forward a few years, we now have a team under the Mozilla Research umbrella who's working full-time on improving the language. And so we released version 1.0 last year, and every 6 weeks we now release a new version. So we just released 1.13, and there is a large community around the language now. So not only do we have developers working in Mozilla on it, some of those developers are part of what's called the core team. And those are the people that decide the future of the language and help shape where it's going as time goes on. So in addition to our employees, we have volunteers and employees from other companies that are now depending on Rust for their products. And they're helping shape this ecosystem, which is then has a large number of libraries that are being developed by people who are enthusiastic about the language. It's got a lot of downloads happening. Since the last time I gave this talk, there have been 10 million more downloads and 300 new libraries published. So there's a lot going on. There's also the Friends of Rust, which I'll show you. There is a page showing lots of different companies that have told us, yes, we are relying on Rust in production. We are very excited about its prospects. So lots of cool things going on there. So the reason for Rust is that we have, in the past, 10 more years of using Firefox and JavaScript in Firefox, sorry, C++ and JavaScript in Firefox, we've come across the fact that there are some pervasive problems that are caused by using C++. And that is, writing code that makes use of multiple threads is very difficult. And it's easy to write incorrect code, and it is very easy to write code which is unsafe. And that translates into security exploits, things that are stored by governments and by hackers all over the world and used to steal data from our users and take over their computers, using the browser as a vector. There's a huge number of these that are released every year by security investigators. And there's competition showing who can pwn a browser the quickest. So we looked for ways to address this by creating a new language. And it turns out that actually both of these issues, being making it difficult to write parallel code that makes use of modern hardware, and writing code that is safe and not exploitable, turns out they can both be addressed by introducing the concept of ownership in the language. So let's talk about what that means. Ownership encapsulates two ideas, basically. It is what the owner of a value is, and whether there are multiple owners of a value or multiple users that are sharing a value, and additionally, how long that value, or when that value is actually valid. What is the point in a program in which it's actually safe to interact with the value? And so from this, we can derive a few rules. That if there is only a single owner for a value, that value can be destroyed when the owner goes out of scope, because there are no ways to reference that value anymore. Similarly, if a value has only a single owner, that means that it is legal to mutate it because no one can observe the change to that value. And finally, if you have multiple owners, you need to have something called borrowing, which is you still have a single owner, but other people can observe it, but it can't be changed during that time. So let's talk about an analogy here. If I've got a coloring book and a marker and some friends, we can establish some rules. The coloring book and the marker are my property, so they go with me wherever I go. If I leave, no one else can observe the book or color in it. However, I am able to loan the book to someone else, and that means they're borrowing it from me. But that also means that I can't color in it while they're borrowing it, because that's rude. So they can also choose to lend it to people around them. But that means that if anyone else is borrowing it, they need to give it back to me before they leave, because it's my property, and only I can leave with it. Additionally, if I have the marker, I'm able to color in the book if I have the book. I can also give the marker to someone else, and that means they can color in the book if they have it. That means that I'm no longer able to color, because only a single marker. And finally, if I want to leave, but I don't actually have the book in my possession, there's a problem. Either I need to wait until someone gives me the book back, or I need to actually give it to someone else and say, okay, it's not my property anymore, it's yours to deal with. So, ownership in Rust. If we have a type, we call a coloring book, and it gives us a constructor that returns a new instance of a coloring book. We can say, okay, here is a variable called book, which we will say stores this coloring book value. That means that we can now call this color method, which will change the coloring book in some way. It'll color in it. That's fine. We can mutate it because we only have a single owner. So what happens if someone borrows the book? We now have another variable called borrowed book, and we use the ampersand to show that we are borrowing the value that is stored in this value called book, or this variable called book. This is an immutable borrow. That means that it is not possible to mutate the original value anymore because it's borrowed. So we cannot color in the book while it's borrowed by someone else. This follows our analogy. The other thing, however, is that if someone else is borrowing the book, they also cannot color in it. They don't have the marker. In this case, they don't have, or they only have an immutable borrow, so they cannot mutate it. So we can work around this by using what's called a mutable borrow. This says, okay, give me the book and give me the marker. And then they have both the elements necessary in order to actually color in it and mutate it in this case. So we have the ampersand followed by the mute keyword, and this means give me a mutable borrow to the value that follows. However, the thing to note here is that we cannot use the original variable called book in order to mutate it while it's borrowed. We cannot have two different people coloring in it because only one person can color at a time. So let's go back to the example we had before. So we've got a book value. We're allowed to color in it because there's no one borrowing it. Then on the next line, we have an immutable borrow, and we're not allowed to color in the original one again. This is fine. It's borrowed, can't be colored in. So let's fix this. This is where we talk about lifetimes. Because remember how I said that we can figure out when a value is valid? So this means that if we have a scope here, delineated by the curly braces, this means that inside the curly braces, anything that is unique inside there no longer exists outside of them. So if we create this borrowed book value, and we borrow from the book value, we have an immutable borrow, and that's fine. We can then do something with this that doesn't require mutating it. We can just look through the book. We can investigate it. And that doesn't mutate it, that's fine. And so previously, calling color on the original book value would have been an error because it was borrowed. But now, the borrow no longer exists because it is only valid within the scope of these braces. And this is how we can control the scope of a borrow. So finally, we can also transfer ownership. This is how we talk about giving away the book to someone else. By default, we can say, okay, we'll create a new variable called book2, and it will have the contents of the book variable, and we can now color in book2. That's fine. It's not a borrow. There's no ampersand there. We are giving control of the value to another variable. And additionally, if you try to compile this, you'll note that we can no longer interact with the book variable. Because we transferred ownership, it doesn't exist anymore. The compiler knows this and can say, nope, that is not safe, what you're trying to do. And you'll note the link up here actually goes to a playground where you can play with the Rust compiler in your browser, and there's a sample for this code that you can experiment with there already prepared for you. So we understand borrowing a little bit better now, especially with the analogy, but how does this actually help in practice? How does this address the two cases we talked about before? Using values after they're no longer valid, and using values or writing code that makes use, or writing code that works with multiple threads at the same time. So first, with use after free values or use after free problems, those happen in C++ because you'll have pointers in your code, but the pointers are not associated with the value that they're pointing to. So you could delete the memory that they're pointing to, but the pointers are still pointing at that memory. And so if you aren't careful, you can end up using pointers that are pointing to invalid memory. So in Rust, the compiler is actually tracking this. So it doesn't let you write code that has the potential where pointers could point at memory that no longer is valid. And that means that you're always taking borrowed pointers to values where the compiler says, okay, I know exactly how long this value is valid for because I know what the owner is, and therefore any pointers to it must no longer exist before the owner no longer exists. And additionally, you can also, because the Rust compiler also tracks outstanding borrows, you can also say, okay, we are guaranteed that there's no way to mutate this while anyone else is borrowing and trying to look at the value. And this addresses another case where this can happen in C++, where you end up having changing a value, like reallocating a pointer or something, while other things are trying to point to memory that it was relying on. And as for parallel code with multiple threads, the issue arises with data races where you have multiple threads that are sharing values and they're also mutating them. It's the same issue we just talked about, basically, where they're not coordinated in figuring out when it's safe to write to a value and when it's safe to read from a value, because you might get intermediate values when a write hasn't completed yet. So Rust addresses this by forcing you to either transfer ownership of values that another thread needs to use so that two threads cannot share the same value, or ensuring that any values that you do share between threads abide by certain restrictions that prevent invalid writes from happening, invalid reads from happening, so that races can't happen and it's impossible to write code that is not actually thread safe. So how this actually applies to what we're doing at Mozilla is that we've got the Mozilla Research Organization, and so part of them are working on improving Rust the language. However, another part of them are working on building a brand new web browser because Firefox is not enough. This one's called Servo, and so we're building it from the ground up. And the reason we're doing this is that there are decisions that were made, design decisions for Firefox that were made like a decade ago, which are very difficult to change at this point in time. It'd be a huge amount of work to redesign parts of Firefox that we think could be better, but it's also difficult to verify whether that would be a worthwhile use of time without actually doing it. So we compromise by creating a brand new browser where we can actually try out new ideas and give ourselves a playground to experiment with things we could do better in Firefox. And if they work out, great. We can then start transferring them back into Firefox and integrate them. Additionally, this means that we can experiment with like laying out pages, doing that in parallel rather than all other browsers today, which do them sequentially in a single thread. We can do things like experiment with the way that we draw things to the screen and do it more like a computer game. We can do things like change the way that we're managing memory for the parts of a web page so that's more integrated with the garbage collection that the JavaScript code ends up interacting with. And so all of this are things that we're doing in Servo, and we're getting some great results, and some of them are already being integrated back into Firefox. So we're already shipping code today in Firefox as written in Rust. For example, we have parts of our media stack where we have code that's just responsible for reading parts of video files, which has been a source of security vulnerabilities in the past, and there's no reason that should be the case. So we rewrite it in Rust, and we get safety by default. So that's shipping in Firefox today. You've also got a project called Oxidation, which is a list on the wiki of all the pieces that were in the process of writing in Rust in Firefox today. And some of the most challenging ones that I mentioned previously, the rendering engine, the style system and layout, those are being integrated into Firefox today as part of the Quantum project. And so you can basically expect that the amount of Rust code in Firefox will increase over time. There's been a lot of really good results panning out so far, and especially for areas where they shouldn't be security sensitive, but they need to be high performance. Those could be great places for integrating Rust code, because you get those by default. So if you'd like to know more about Rust and Mozilla, you can check out the Rust Playground I mentioned earlier. That allows you to experiment with writing Rust code in your browser. We've got a nice introductory book that covers everything you need to know about the language, called the Rust Programming Language, which is accessible from the language website. And then we've got IRC channels, which are designed for both beginners who like to interact with other people who really want to answer your questions right there, as well as a huge community in the Rust channel who really adore asking and answering questions. That's all. Thank you very much. Any questions? Yes. What would be a good way to start contributing or participating? There's a few ways. So if there are libraries that you would like to use from Rust that don't exist yet, writing either libraries from scratch in Rust to scratch that itch, very handy, publishing that for the community, or if there are libraries written in C, which already exist, which would give you functionality that don't exist in Rust yet, then writing bindings in Rust around that C library is very useful, because that allows you to build safer abstractions on top of things that would otherwise be potentially unsafe, but it's really easy to integrate with C code, which is one reason why it's working out so well to integrate Rust in Firefox. Yeah, there's lots of other suggestions on the Rust website of ways to participate in the Rust community, if that's what you were asking. Yes, Lucy.
One thing is compelling reason that you would give for someone to learn Rust, especially for people who are worried about investing time to learn if, like, they may not never use it again.
What are the most compelling reasons for someone to learn the language and potentially start participating in contributing? I think one thing I've heard is that actually people who don't already have what's called like a systems programming experience, so like a lot of experience using C++, for example, one of the lower level languages, people coming from like a web development background or something, people writing a lot of JavaScript, Ruby, Python. What I've heard is that people coming from those languages are actually getting their first experience doing low-level programming stuff, but in a way which is much less daunting than C or C++, where they know that the compiler has their back in ways that the compilers for C++, for example, don't. And it will tell you when you're making mistakes, and it won't let you make those mistakes, which is pretty exciting. There are two people who I know who come from like Ruby, JavaScript backgrounds who are now putting together a series of tutorials for teaching people how to do kernel programming using Rust, with the intention that like other people are coming from those like high-level backgrounds and trying this out for the first time. So like there's a lot of ways to experiment with things that traditionally has been rather unapproachable for large segments of the developer population. That's a pretty compelling reason, really. And yeah, like, and even if you do have experience doing like C++ and low-level things like that, I find that not having to worry about whole classes of problems you can make as a developer in those languages makes a huge difference. It allows you to reason about your code better. It allows you to be more adventurous with your code. Mm. Yeah, so the question was, one of the things people have talked about is that Rust should be able to make the process of like refactoring your code easier, safer, just generally less complicated and less uncertain. And has there been talk of that? And has there been evidence of that? And yes, there was actually a really great blog post in the past couple of weeks of someone who was refactoring their code, and the compiler kept pointing out ways in which it would not be safe to refactor it in that certain way because it was shared between threads. And it just, like, he would fix that thing, and it would go down the rabbit hole a little bit further and say, oh, now this isn't safe anymore. And it was this very like compiler-guided refactoring session, which he wrote about and documented top to bottom. And it's great. It seems to just verify the premise that like this does prevent you from making mistakes. All right, let's call it there. Thank you for attending, everybody.